Hi. Okay. So yeah, so it is not like anything. It will be like, I think ma'am has covered all things from week 9 to 12, I guess. So today maybe I'm not going to go into details of any of the concepts in week 11, 12. What we'll do is we'll just solve some questions. If you have any doubts, you'll just ask me the questions. We'll solve those questions today. Fine.
Sir, I have a doubt in a question.
Yes, yes. We'll
Can
solve all the questions. Maybe you can
can
think
I
of this as a
send it in the chat?
open session for 1 week. Sure, sure. Okay. First of all let others to join. Do you have any other session at this time from Maths One or CT or something?
No, sir.
No,
TA
right?
session, sir.
Okay. But TA session is there. Okay, fine. So no, I'm talking about instructor session. It's not there, right? Okay, sure. So how to compute the CDF of derived variables means
So by derived, I mean function of other random variables.
okay. Okay. So okay. I'm not sure. Who is it? So the question is to participate in a game of prediction of runs scored by a team in cricket match. One needs to pay an entry fee of rupees 20 if the net gain is uniformly distributed between minus 20 to 20. What is the probability that a person participated in this game will have absolute net gain or what it is, absolute value or absolute net gain less than 4 rupees? Okay, fine. So let's start with that question. I will come to this question also, how to compute the CDF of the function of random. Fine. Okay, are you able to see my screen?
No, sir. It displays Mayur sir has started screen share. Yes, sir.
Okay, just
Yes.
Yeah,
it's
now
visible. Okay. Am I audible properly?
Yes, sir.
Okay. Fine. Just a minute, I'll just see the question once again. Entry fee is rupees 20, and if the net gain is uniformly distributed between minus 20 to 20, what is the probability that a person participated in this game will have absolute net gain less than rupees? Okay, so yeah, Raj Deepak, I'll solve some questions, right? That will be good because I don't want to go again into the concepts. So okay, this is the question, right? Can you tell me if x is my random variable, for example, and I'm saying that if what is the winning? Winning is uniformly distributed between plus 22 or minus 22 plus 20, right? Correct?
Yes, sir.
So what do you think the values taken by this random variable x, or what is the range of this random variable? That means the values taken by this random variable. So this is uniformly distributed. That means it will take. Okay, is it a continuous function or What do you think? Is it's a continuous random this uniform random variable is a continuous random variable or a discrete random variable?
Continuous, sir.
Why?
I think it's discrete, so it's discrete,
It's a
uniform.
discrete, right?
Right.
Right. So you can actually check it from this also with this square bracket. If the square bracket is there, then this is an indicator of a discrete random variable, right? And if the round bracket is there, then that is indicator of what? Round bracket, or maybe I think it's curly bracket for continuous distribution. But for I think for this case, it's a discrete random variable, right? Discrete uniform random variable. Is it correct? All of you agree with this?
So I think curly means discrete.
Yeah, curly means, sorry, curly means
I
discrete
think
or
yes, sir. Curly means discrete.
okay. Okay, I'll just check once again.
Yes, sir.
Maybe
Continuous.
fine.
Sir,
1 minute, just a
sir,
minute. I'll just yes.
sir, like, can you also explain the when you're explaining the questions, like, can you also explain that concepts along which are and all, like, there with that question involved in that question, the concepts which and all involved in that questions,
Yes.
like,
Yeah. Tell me. Yeah.
especially like when it comes to like week 10, 11, and 12, sir.
Yes. Yes. Sure. I will explain all the concepts. It's not a problem. Okay. Anyway, ma'am has covered most of the topics. I'll just tell you that how we can identify that this is okay. You understand? This is uniform distribution, and when this is round bracket, then this is denoted by what? Continuous random variable. And if I go back again, I'll check whether okay, ma'am didn't cover this one or what?
Normal distribution will not come in the exam, right?
No, sir. Actually, I think you guys have got the notification regarding that, right? I think on Sunday session I told you that the normal distribution will be there, but later on I have spoken to other colleagues of mine, and we have decided that it won't be there. Fine. Okay. Okay. I'm just.
Sir, sir, it is open bracket or closed bracket. It doesn't matter.
Why?
Sir, we are taking x less than equal to a. It is same as x less than or equal to a.
That is for continuous variable.
But it follow the formula of uniformly distributed. U is equal to a comma b.
The doubt is whether it is a continuous or a discrete distribution. We have not been given either.
It is in the p by q of n term.
Sorry, what happened? What happened? Okay. So actually, see, when I say that if it is in close bracket or open bracket, I understand that when this is a continuous random variable, the range doesn't matter, right? Okay, open interval or closed interval. But when I'm going to define a random variable, like uniform random variable in this case, right? So the representation of it, like how to identify whether this is a discrete random variable or a continuous random variable, that identification purposes, for that it is important. You understand? So I think this question is there. Okay, I think okay with this bracket, I think it's a continuous random variable, right? Continuous uniform distribution. I'll assume that one. Okay. Can you tell me from where it is? This question is which week?
So it's a p by
So from PYQ of
Previous
int term.
Okay, fine. Okay, so yeah, so if this is a continuous random variable, continuous uniform random variable, okay, can you tell me what is then what is the PDF of this? Let's say x is
1 by
uniform.
4.
So what will you be doing today?
I'll just take the questions and I will try to solve all the questions. Okay.
From 1 to 4. It's only doubt session, sir.
Yeah, it's a doubt session. I'm not going to cover any concepts
Sir,
here.
sir, just a request.
Yeah, tell
Sir,
me.
can you please send the PYQs of n term?
I think you guys are having, right? I think that is open source, I guess. You'll get it from anywhere. I'm not sure like about it, but I think you'll get it from like lot of platforms are there, which is where it is available, I guess, right?
So we are not getting access to the PYQ which our TAs are doing.
It is telling us to request access.
So
Okay,
the
so
recording we are getting and the PDF also.
okay, fine. Okay, I will try. I'll talk to them and I will
Hello, sir.
Sir, can you give your
solve
email
this
ID?
one. Okay, fine.
Hello, sir.
Okay, yeah, tell me.
When I access the recording of the TA session of math subject, I denied. matlab, I don't get access.
Okay,
Why,
but
sir?
whether you used to get it from from the previous one or like this happened only for this week from the
No,
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 sir,
initial week.
every
previous
time.
one. Every time we
Every
access.
time.
When
So you are a qualified student, right? Or you are a term student?
Sir, term student.
term student, sir.
Then I don't see you guys are having that at the rate ds dot study dot itm ID, right?
No, sir.
No,
Sir,
sir,
we
we
just
have not.
No,
qualified
sir.
2 months ago.
Then you are the qualified student, right? You are accessing through your email IDs, right?
Yes, sir.
Whatever
Yes,
your
sir.
question ID.
Yes, sir.
Okay, I think see that initially I think during week 1 to 4 the issue has happened. If all of you are, I think you're aware of it, and due to that some IDs are already blocked.
Oh,
So that's why you guys are not able to
so,
access TF
sir,
sessions
when we got the student email ID from the.
after this enter.
Okay,
You
sir.
get it. Okay. Okay. Let's
Okay, sir.
focus on this currently. So
Okay,
x
sir.
is uniform between minus 20 to 20. What will be the PDF of x? So PDF of
1 by
x
40, sir.
generally which is 1 upon b minus a, right? And it is 1 upon 20 minus of minus 20, which is equals to 1 upon 40, right? Okay. So 1 upon 40 is my PDF of the random variable, and with my random variable is between 20, right? Okay. So I'll write this PDF as like this. Maybe 1 by 40, and it is between 20 and let's say 0. Otherwise, okay. Okay, this is the PDF of x. But what I said is, or what is the question? The question says, there is an entry fee of what 20 rupees, right? There is an entry fees of 20 rupees. So let's say I have defined a new random variable y, which I called as net gain, right? How should I represent this y in terms of x? It should be x minus 20, right? That is my net gain, right? Because this x when this is between minus 20 to 20, that means, okay, what do you mean by minus 20?
No, sir. Actually, X itself represents the gain.
Is it? One needs to pay an entry fee if the net gain is uniformly distributed. Okay, I think then that 20 rupees is not having any. Okay, fine. Okay, then this is not a problem of. Fine. I thought this is a problem of function of random variable. Okay, then it's fine. Then I think it's very easy question, right? I don't see
So,
any issues in this.
Yes, sir.
So the question is, I need to find what is probability that my net gain is less than
4.
less than 4, right?
4, sir.
So how to find this? So it will be, I think, between minus 20 to plus 4, right? Correct? And this is 1 by 40 into dx. This fine? Is
No,
this
sir.
correct?
It is from -4 to 4, not from -20 to 4.
Can
Bro, that a
directly
person
apply the
what can
formula of
only
CDF,
have okay,
CDF X
absolute value
Not
of
getting the answer from applying the
okay.
CDF formula.
X
No,
minus
no,
A
I'm
or
saying
B minus
okay, I'll tell you. Okay, what is it? The question is I need to find the absolute gain. Okay, absolute gain which is less than 4, right? Less than 4. So absolute gain less than 4 means what? Okay, I'll just draw just give me a minute. Okay, so my random variable is between minus 20 to plus 20, correct? So it is 0. So absolute value of 4, what does that mean? Either plus 4. So less than 4 means what? Which area? Okay. What do you mean by this? Absolute of x is what?
minus
Plus
4 to
minus,
4.
right? Right. So correct. So it is between this, right? Less than 4 is what? This area. Is correct? Okay, do you understand this at least? First of all, do you understand what is the meaning of absolute value?
Absolute value of 4.
Absolute value of 4 means, or absolute value less than 4 means, either it is less than plus 4 or it is
It is
greater
greater than
than
minus 4.
minus 4, right? This correct?
Yes, sir. Yes, sir.
Okay, and what is this probability of x less than 4? It is what? Fx of 4 is fine. And this probability will include which value? This red portion, right? Correct? This is the definition of a CDF, correct? What is the definition of CDF? Definition of CDF, what is it? So probability
Probability of
that
X less than
less
X
than,
is equal to X minus A upon B minus
yeah, but it is from where? Let's say it is actually from minus infinity to plus
Minus
infinity,
infinity plus infinity.
right? And what is it? Here it is fx of x, or this is called as PDF, right? Into dx. Okay,
Of
but
dx.
but what is this? Is actually a lower limit, right? Lower limit, and this is upper limit, right? Oh no, sorry, this is not infinity. This should be up to x, correct? From the lower limit up to x, right? This is the formula of CDF, or this is the definition of CDF. Now think about this. I do not have anything here, right? So let's say I have started from minus infinity, but there is the value of probability until minus 20 is what? It's 0. That's why in this case I just started with my lower limit from minus 20, right? Correct. So actually I can break down this part until this minus infinity to minus 20 fx of x plus minus 20 to 4 fx of x, correct? All of you agreed with this, and this portion is equals to 0 because you see 0 otherwise, right? We have fx of x equals to 0 when it is outside of this range. That is clear?
Yes,
Yes, sir.
Okay, so this is the value of fx of 4. Okay, but I do I need the value of fx of 4, or I need only this part, this portion? I need this portion only, right? I don't need this red color portion. I need only the middle portion. So to get that, what I have to do? I have to subtract this portion right? Currently, what is this? Fx of 4 is what? Which portion it is? It is this portion. Fine. Okay. I need to, so probability of x less than 4 is this portion. I need to now find out this portion, and how to find this? This fx of minus 4, right? So fx of minus 4 is what?
Minus 22 minus 4. Fx.
From minus 20 to minus 4, I need to,
Fx dx.
yeah, here in this case, right? Okay. So tell me what is the value of this. So 1 by 40 is a constant. So it is 1 by 40 into x, and the limit will be from minus 20 to plus 4. Is it correct? This is okay?
Yes, sir.
All of you are okay with this integration? This is a simple integration, right? Okay, if you have any doubts,
Sir, why we are taking only till minus 4, like 4 to minus 4, and not till minus 20?
See, because I wanted what? Absolute gain of less than 4, right? Absolute, what do you mean by absolute of x? Absolute value of x? Okay,
Mod of x.
yeah, mod of x is what? What do you infer from that? Okay, let's say
like if it is
value
greater
is
than
plus
0,
minus.
it will be 4. If it is lesser than 0, it will be minus 4, sir.
No, that is okay. I'll just maybe I'll draw one graph here. Let's say y equals to mod x is one function. So this is mod x. I think you guys have studied this function in mathematics 1. Modulus function.
Yes, sir.
Huh? Okay. So this is 0, right? Okay. So let's say I said mod of 2. Mod of 2. What does that mean? Or
Plus
okay.
minus.
Or y
2.
can be plus or minus 2.
So when x is equals to 2 or x equals to minus 2, the value of y will be what? Let's say, what is it? 2, right? Correct or no? So value of y will be positive, right?
Yes.
So even though you have, so what does that mean? Mod of x, this means I can take the positive value as well as I can take the negative value, but the function will give me what? Only the positive value. So when I say absolute gain of 4, what does that mean? Which values I should care about? Plus 4 and minus 4, right? Whatever is there in between plus 4 and minus 4, correct?
Yes, sir.
Okay, I just don't want to, the graph will not be like this. The graph will be somewhat different, but okay. But see, when I say mod of x, means I should take all the values, or I should at least, so okay, see, the limit should be plus 4 and minus 4, right? I can actually include plus 4 as well as minus 4. So when I said this, so I showed you this line, right? On x-axis, my random variable actually taking all the values between minus 20 to plus 20. So when I say absolute gain of plus 4 and minus 4, let's say this is 0. So plus 4 and minus 4. Now these two are the values. And what is the next statement? It should be less than the absolute value or absolute gain of 4. So less than 4 means what? Less than absolute value of 4 means what? Absolute 4. What does it mean? Either it should be less than plus 4, right? So less than plus 4 means until which portion? This portion, right? Or it should be greater than minus 4, right? This portion. But what is the common portion in between these two?
Minus 4 to 4.
Right, this. So I'm interested in actually this blue colored portion. Okay.
Yes, sir.
right? This is a thing. Generally, will see. Actually, you wanted this probability actually. Mod of x equals to 4. Okay. So what does that mean? Probability that x is. So I can say like this: -4 is less than x plus
Yeah.
4. Okay, this is
We
the
can
meaning
try.
of it. And there is one more method to solve this. So actually I showed you the other method, but we can solve it using the CDF formulas, which is like, okay, so it is, let's say, okay, mod of x equals to 4. That means probability that -4 is less than x less than 4. Okay. Okay, so
We can write this as probability.
okay, so noise is coming. Can you just okay, thanks. Right. Okay, okay, consider this as a and this as b. So what is this? So this is actually f of b minus f of a.
A.
So which means f of 4 minus f of minus 4, right? Okay, so what is f of 4? It is probability that x is less than 4, right? By the definition of CDF, right? This is the definition that f of 4 means probability that x is less than 4. What does that mean? I need to go from actually minus infinity to plus, 4, but like I'll just write down this as, then I'll say f of x into dx. But I know that it is 0 between minus infinity to minus 20. It is 0 dx plus integration from minus 20 to plus 4. It is 1 upon 40 dx, right? We have already defined this PDF, right? F of x is equals to what? It is 1 by 40 when x is between plus 20 to minus 20, since it is uniformly distributed there, and elsewhere or otherwise it is 0. So this actually gives you value 0, and this portion, right? This portion will give you what? Since this is constant, so what is the integration of a what is integration of c into dx? It is c into x, right? So here c is what? It's a constant, so 1 by 40 outside. Integration of dx is what? X. But we have to put the limits as it is from plus minus 20 to plus 4. And how to put the limits? It's I have to, you know, put these values here instead of x. So it is 4 minus of minus 20, right? So it is 1 by 40 of what? 24, right? So if you can think about it, it's become 6 by 10, or which is 0.6. This is okay? Until this is fine?
Yes, sir.
Okay, all of you, I'm just skipping it for a moment. You just go through it and think about it. Okay.
Sir, but the answer is incorrect.
No,
Answer is
no,
1
no,
by
no.
5.
Answer. No, we haven't completed answer yet, right? We have just found out f of 4. What we have to find out next?
F of
F of minus
minus
4
4.
also, right? And then I have to subtract this value from there, right? Correct?
Okay, so okay.
Fine. So
Thank.
I'm just going to find out what is next. F of minus
So can you
4.
please explain from the CDF formula? It is easier
I'm just
than this.
I'm just doing this one only, right? This is a CDF formula, right? What is f of minus 4? This is CDF only, right?
Yes,
The
sir.
CDF. What is f of minus 4? It is probability that x is less than minus 4, right?
Yes.
Okay. Can you tell me what are the limits here then?
Minus 20 to 20. Minus 20 to minus
About,
4 here. Minus 4
right?
here.
Yeah.
Yes, sir.
And 1 by
1 by
40.
40 dx.
So which
dx.
is nothing but what? 1 by 40 into x, and this will be minus 22
Minus
minus
4.
4. So yes, think it's 1 by 40 into minus 4 minus of minus 20. This becomes 1 by 40 into how much? 16 plus 16,
Yes.
right?
Yes.
And if you think it's 2 by 20. So yeah, 2 by 5, right? Which is 0.4. Is that correct?
Yes, sir.
Okay. So I found out which value now? F of minus 4. This value was equal to f of 4, and I'll substitute these values here.
Then the value is 1 by 5. Yes, sir. Correct.
So this will become what? 0.6 minus 0.4, which is equals to 0.2, right? This is the correct answer. So how I have approached this, okay, or how this, from where this formula comes from, right? For that we have to think about this, this whatever the picturize in the linear form. So I'll just again once again explain this. If you have any doubts here, just think it once again, right? So I had a uniform distribution, right? I had
Sir,
uniform
if
distribution.
we directly integrate from the minus 4 to 4 and PDF 1 by 40 dx, then we easily get
That is
1 by
also
5.
fine. Yeah, that is correct. Okay, but again, that is something you should know, like how to do that. That is also fine. Even though again that will give you the same answer, right? That's nothing but what we have done now. And this was whatever I shown here was from the basic definitions of CDFs, right? Fine. That is also fine because we are just integrating between minus 4 to plus 4, and hence I can directly integrate between minus 4 to plus 4. That is not a problem, right? I can actually integrate from minus 4 to plus 4. There is no issues in that, right? Correct? Okay.
Yes, sir.
So actually I was interested in this portion, right? And to find out this portion, I can actually do it from minus 4 to plus 4, 1 by 40 dx, which is nothing but 1 by 40 x from minus 4 to plus 4. So this is 1 by 40 into 4 plus 4. So it is 1 by 5, which is 0.2. Okay. But actual meaning of it is what? I have to find out uh, f of 4, then I have to find out f of minus 4, and then I have to subtract this green portion from the blue portion to get this portion, right? And that is what we have done earlier. Is clear?
Yes, sir. Clear. Sir. Thank you, sir.
Okay, all of you got this?
Sir, it is
These
the
two
only case.
approaches.
Sir,
Sorry.
it is the only case when absolute.
Yeah, when I said absolute gain, that means I need to check between minus 4 to plus 4. Otherwise, we can have any other problem where we can solve this. Okay, it's the case where absolute gain was mentioned, and hence I need to integrate between minus 4 to plus 4. In other problems, it will not be the same. So you can just give me any problem. I will try to solve that. If you have any problems from practice assignment or grade
Sir, please
assignment,
solve some
Yes,
previous
sir.
year question.
I have a little doubt.
tell me now. Tell me any question. Tell me.
Yes,
I'll just solve
sir.
it.
In activity question 12.1,
What is the question?
The beginning of
sir,
the
question number 5.
I've raised my hand from the beginning of the session too. It's already raised.
Sorry. Okay, you can actually. Okay, you can tell me your names, and I'll try to
So,
solve this.
I'm Suja, sir.
sir Gurmukh.
Yeah, tell one by one. Okay, fine. Yeah, tell me.
Okay, sir. So can I share my screen, sir?
Okay, share your screen. Okay, fine. Sujal, right? Who is going to ask now?
Yes, sir. Me, sir. Me, sir.
Okay, Sujal. Yeah, go ahead. So today my agenda is to solve problems. How many I can solve it today. So we'll go it slowly. No issues. Yeah, Sujal.
Sir, it's not allowing to share. You cannot start screen share while the other participant is sharing. So,
Okay, I'll just stop my sharing.
sir, the one of these, sir.
Which questions you want me to solve?
Sir, I have a few, and this is one of them, sir.
Sorry.
I have a few doubts, and this is one of them, sir.
Okay. This is what if a random variable x is exponentially distributed with parameter lambda and probability x less than or equal to 1 is equals to probability x greater than 1, then what is the value of variance of x? Fine. So if you can just stop the screen, I'll maybe like lot of you are having the same problem, same issues maybe. That will be okay. That will be clear. Just let me know the question. Okay. Uh, can you just once again tell me the question?
Sure, sir.
You can
Uh,
just tell me the like whatever given is there directly.
so if a random variable x is exponentially distributed with parameter lambda and
Yeah.
the probability of x is lesser or equal to 1 is equals to probability of x greater than 1, then what is the value of variance x?
Okay, done. Okay. Do you know what is PDF of exponential?
Yes, so lambda e to the power 1 minus e to the power negative lambda x.
That is CDF, right? Okay. CDF
Then
is
e
1
then
minus e to the power minus lambda x. That is CDF, and PDF is actually it is like this,
lambda
right?
e to the power negative x.
Lambda e to the power minus.
Minus lambda x. Okay, but in this case we are okay if we know CDF itself, because we are going to find the probabilities, right? Okay. Actually, I can find the probabilities from PDF, but I know the formula for CDF, so I'll use that one. Okay. What do you mean by probability that x is less than 1?
F of
This is
1.
F of
right?
1.
So
This is f of 1, right? What is the
1
formula
is
for
equal
f
to
of
F.
1?
1 minus F
1
of 1.
minus F of 1.
So it is 1 minus e to the power
E to the
negative
power
minus
minus
lambda, right?
lambda 1.
Right.
Yeah.
What is okay? But yeah,
Yeah,
multiplying
yeah.
with 1 is like right. What about this probability that x is greater than 1? Probability
oh,
that x is greater
yes.
than 1. This is
Oh, 1
1
minus
minus
yes.
probability that
1 minus. Yeah.
probability
Again
that
1
this is
minus.
right.
Sorry,
So
sir, I just joined now. Can you please, sir, what are you doing?
I'm just solving some questions, whatever the doubts students are having,
Is it
and
a
this
doubt,
is
sir? Your own question, sir.
no,
Your
this
own
is a
question
doubt.
means
No, sorry, just let me finish. So this is the question from previous year end term. I
okay,
think
sir.
some of the student has told me to solve this, so I'm just solving it. So the question is, a random variable x is exponentially distributed with the parameter lambda, and this is the condition given that probability that x is less than or equal to 1 is equals to probability that x is greater than 1. I need to find what uh, the variance of x. Is it correct,
Yes, sir.
Sujal?
Variance. Yes, sir.
Yeah.
Variance.
So I found out first probability that x is less than or equals to 1, which is nothing but f of 1, right? F of 1.
Yes, sir.
And I know the CDF of exponential is 1 minus e to the power lambda x. I just and just substituting the value of 1, I'll get this equation 1 minus e to the power minus lambda. Similarly, if I wanted to find what is probability that x greater than 1, actually I can
E to the
greater
1
than
minus lambda.
so that I can actually convert into this 1 minus probability that x is less than or equals to 1, right? This complement of this event only. Okay, then if I okay 1 minus what is probability that x is less than or equals to 1? It is 1 minus e to the power minus lambda, correct? Which is already we have seen here. So I'm just substituting here, and if I do the calculations, it will become e to the power plus e to the power minus lambda, right? And from the given condition, I know this has to be equal, right? So let's say this is okay. This is then 1 minus e to the power minus lambda is equals to e to the power minus lambda from the condition given in the question. Is it correct?
Yes, sir.
Okay. So the next step would be 1 is equals to 2 into e to the power minus lambda, right?
Yes, sir.
Yes,
All
sir.
of you are okay?
Yes, sir.
Okay. I just shifted this minus e to the power lambda to the right hand side and get this one. So I'll say 1 by 2 is equals to e to the power minus lambda. Okay.
Yes, sir.
Okay. Then I'll perform logarithmic operations on the both sides. So it will become ln of 1 by 2 is equals to minus lambda ln of e, right? And ln of e is equals to what? 1, right? So this is the situation now. Okay. If I this minus sign, if I give it to the right side, then this will become ln of 2. You understand the logarithmic rules, right?
Yes, sir. Yes, understood, sir.
All of you are okay, like how this becomes, or else I'll just explicitly write both the things. Okay, I'm not sure, like I don't know, like all of you know this or not. Just okay, I'll just take this minus sign to the side. It will become minus ln of 1 by 2 equals to lambda. Okay, minus sign I'll keep it here for now. What do you mean by ln of 1 by 2? Actually it should be ln of 1 minus
minus ln 2.
ln of 2. Okay, is equals to lambda. And if I uh, okay, this will become minus ln of 1 plus ln of 2 is equals to lambda, and ln of 1 is what? Is
0.
equals to 0. So lambda is equals to what? Ln of 2. And I think that should be okay. That is not your answer. Okay, this is the
Sir.
value of lambda.
Yes, sir,
Now I
understood.
need to find variance of x, and variance of x, and x is exponentially distributed. What is variance of
1
an
by lambda
exponential
square.
distribution? 1
1 by
upon
lambda square.
lambda square. So eventually it should become 1 upon ln
ln 2 by square.
2 square, right? Okay, you can now just check which option is correct and you'll get the answer. It's fine.
Sir,
All of you are
it's
okay?
correct, sir. It's correct, sir. Thank you, sir.
Okay, all of you are okay with this? If you have any doubt, just let me know itself.
Sir, can you just scroll up
Sir, I
little
have
bit?
one doubt. And I'm waiting for a long time.
Yeah, I will just take,
Please
don't worry.
clarify that.
This is okay?
Sir, can you just scroll up little bit?
Okay.
Sir,
Yes, sir.
I have a question in
Shall I ask?
11.5 weekly asset.
So
Yeah,
first,
I'll do.
how to like calculate the
Sir,
CDF of functions of variables.
Right. Right. So that is, so in when you're actually dealing with continuous random variables, right? It's better to know the CDF of a random variable. If you know the CDF of the random variables, you will be able to easily calculate all the probabilities. Because why I'm saying this? Because you see, what is the definition of a CDF of a random variable? It is nothing but probability that x is less than the value taken by the random variable. Okay, so here what we are actually finding out, we are finding out the probabilities. So the CDF will always help you in finding the probabilities better. So if you have any continuous random variable with you, you can actually directly go and find out what is the CDF of the random variable. Anyway, if you have PDF, it's fine. You can actually integrate with respect to that PDF, and you will find the answer. And that is same as that of finding out the uh, CDF of a random variable. Okay. Okay. So let's if you have any other question, just let me know. Okay, tell me. Somebody has
Sir,
asked me the question from the week 12 or something, the activity or
yes,
something
sir.
else.
It is sir 12.1.
Yeah, can you tell me the question?
Okay, 1 second.
Huh.
Yes, sir. Sir, in the question we have given PDF and we have to find the CDF.
Okay, what is PDF?
PDF is fx is 0.25 for -1 to 3.
What is it? Is it a discrete random variable or continuous random variable?
No, sir. It is continuous.
Okay, what is it?
It is 0.25 for -1 to 3. X range to -1 to 3 and 0 otherwise. And we have to find the CDF.
We have to find the CDF. How to find CDF? I have to find
Sir,
f of x,
we
right?
have to integrate the
Yeah,
PDF.
yeah. So okay, I'll do that, right? So maybe so you know the answer, right? So I don't know like why you're asking this question.
Sir,
Okay,
actually I solved, but
okay, you are
I'm
not
not
getting
getting. Yeah, yeah.
answer. Fine.
I
So
get the first and second value, but the last value I'm not getting.
okay, so I'll just x is equals to this is the only PDF given, right? There is
Yes, sir.
nothing else given, right?
No,
Okay, so from where to where you should integrate from
sir, we should integrate for. Uh,
-1 to 3, right?
yes, sir.
And what is it? 0.25 dx, correct?
0.25 dx. Yes, sir. It will be
So 0.25 is
0.25 dx
constant. So this x from
minus
-1
1
to
to 3.
3,
Yes, sir.
0.25. It is 3 minus of -1.
Minus 1.
So actually 0.25 is 1 by 4 into 4. This should
Which
becomes
is
1.
1.
So it is okay, but this is not a PDF. This is actually the entire region. Actually, we have to find,
Yes,
right?
sir.
So I need to find what is the CDF of this random variable, correct?
Yeah.
So by this thing, actually, you will be able to see that this is a valid PDF, right? Because within this range, you are getting +1. So if I wanted to find the generalized formula of CDF, I have to integrate between -1 to small x. Okay.
Okay.
So now this is 0.25, right? 0.25, it's x from -1 to plus x. This 0.25 is 1 by 4, and here it is x minus of -1. So what is it? 1 by 4
X
x
plus.
plus 1. And actually, you can have any forms of it, maybe x by 4 plus 1 by 4, or this one, or maybe like this 0.25 times x plus 1, anything. Right? Is it the correct answer?
Actually, sir, there is options available like
Hmm.
0 for x less than -1 and 0.25 for x belongs to -1 to 3 and 1 for x greater than equal to 2. So I got the first two, but I'm not getting why it is 1 for x greater than equal to 2. It should not it be 1 for x greater than equal to 3?
What do you say?
Should I share my screen?
Okay, fine. Just show me the screen. It will be better. So whatever CDF you have found out, this is probability that x is less than or equals to that value, right?
I have sent chat. I have sent a question in chat. Please look it in this. This is from week 1, I think.
Week 1.
Yes,
Okay. Why week 1? You guys are having doubt.
I will move
Okay.
down.
Okay. Where it is? Siddharth, huh?
Yeah, yeah.
Okay. I'm not able to zoom it. I don't know. Okay, Siddharth, I'm not sure like zoom this one. Okay.
What
Rating.
unimodal means?
Huh? What?
Unimodal means?
Unimodal
What?
means only one model, only one mode available. Okay, that
Yes.
is unimodal. For example, so suppose you have the data set like this, right? So this is 2, 2, 3, 3, 3, let's say 4, 5, 6. What is the mode of this data?
3.
Mode is 3. So only one mode is available, right? In
Yes,
this
sir.
case, it is this data set is called unimodal. when you have data like this 2, 2, 2, 3, 3, 3, 4, 5, 6. What is the mode?
And 2.
2 and 3, right?
Yes, sir.
2 and
So this is not unimodal because we have two modes, right? So unimodal is if your data set contains only one mode, then that is called the unimodal data set, right? Okay.
for the
I think this is
rating feedbacks is poor, good, excellent. In this case, we cannot say, right? What
okay.
is more?
I'll tell you. Yeah, 1 minute. I'll just. So this is your question, right? This is a question from Siddharth, right?
Yes.
Okay, so ratings feedback as poor, good, and excellent of 5 customers it's collected in a shop. If feedback of two more customers are recorded, then choose the correct options. So let's say we have got like 5 feedbacks or 5 feedbacks from the customers, and okay, so assume initial data was bimodal. What does that mean? Bimodal, we have two modes available, correct? So let's say we have these two modes, poor, poor. So I'm just representing P for poor, good. I'll represent G and E for excellent. That is fine.
Yes, sir.
So let's say we have two poor, two good, and one excellent. If this is okay, it can be any other scenario, but I'm just taking this scenario. I don't know what is actually the data set, right? Okay, if feedback of two more customers are recorded, what do you think? Let's say they have given poor, poor, right? Both of them have given poor, poor. Then this data set will become what? Unimodal, correct?
Correct, sir.
Correct. So if somebody has given the two other customers will give, let's say, EE, both excellent. What will happen?
E will be mode.
E will be mode, but whether the data will be unimodal or bimodal?
Trimodal.
Unimodal. No, how can it be trimodal? So just let's say this is my data set, right? The new data set. Then E becomes the mode instead of P and G, right?
Yes, sir.
So it will become unimodal. So that means new data set may change as unimodal. Okay, let's think about other scenarios. One customer has given P and another customer has given G. So this data set will become what? Or this data set will remain bimodal.
Bimodal.
That it is possible that it will remain bimodal again. But okay, that option is not there in the options. Maybe we'll go by options itself and we'll try to so okay, how to approach these questions is just go through the options and try to cut down the options, right? If you can have any instance where I can show that this is not the true case or this is not the true statement, I will say it as no. So for example, new dataset will always be bimodal. How to cut down or the statement? If I
Take
say
example
that,
where
yeah,
only unimodal.
yeah. So this when I have PP or EE or GG, right? In that case, my data set will not be remain as bimodal. It will become as unimodal, right?
Right.
So that means first statement is wrong.
Wrong.
Definitely wrong. Okay, because it says always. It's not always true. It may be bimodal, but it may be unimodal, right? Okay. So so that means my first statement is wrong. Again, that means my second statement is correct. Fine. New data set may change as unimodal. Okay. What about the third statement? Median of the new data set will always remain the same. What is the median in this case?
Good.
Median is good. Okay. Median is good. Now if I add two new points as PP, okay, then what will be my median? Will it be G or will it change? So PP when I added and then I have to arrange this in ascending order. Now this will my data set will the ascending data set will look like this. In this case, what is my median?
P.
P. What does that
It will change.
says?
It will
That
change.
means it may change. It may change, right? It may change, and hence option D will be the correct option, but option C will be wrong option because it says always. Always is not a correct statement to say, because I have some instances I can show that this statement is wrong, right? Understand?
Understand. Thank you, sir.
Okay.
Sir,
Hmm.
sir, whenever the number of points changes, the median also differs now, as the median is related to number of the points.
You can say that, but how the new data, the new ratings will be GG, for example. Then this data set will become, when I arrange it in ascending order, it will become PP, GG, GG, and E. In this case, what is the median?
G is the median, sir.
So that means my median remains the same. Okay. So how your data can be changed? It depends on, like, accordingly my median will change or not. And hence this statement, that's why it is wrong, because it says always. It may remain same, but always is not the correct case, because I have shown one case
Yes,
where
sir.
the median has been changed. Okay.
Yes,
Okay.
sir.
Anyway, this is
Okay, sir. Got it.
this. Okay. Fine.
Sir, there are some questions in the chat. Please frame those.
Yeah,
and-
just tell me. Actually, I think some important questions are there. I think somebody has asked me, like, how to find the CDF of a function of a random variable.
Yes, sir. I'm not able to share screen because someone other has shared.
No, I'm sharing, no. So
Okay.
I'll just stop sharing. You just
Yes,
tell
sir.
me. Yeah, because that is more important questions currently, which I feel.
Yes, sir. This one is the question.
Okay. Okay. This is fine. This is fine. Don't change. The probability density function of a continuous random variable is given by this. Find the CDF. Okay. Continuous random variable is given this.
Sir, take a snip of that question and
Okay, fine. Okay, fine. Okay, you can stop sharing the screen so that I can share and. Okay. Okay, this is the uh, PDF of that random variable, right? This is the PDF of this random variable.
Yes, sir.
So, okay, I'll just use, the piecewise continuous function. Okay, this is a piecewise continuous function. So in that case, I'll draw, maybe, since it, like, we want a generalized case, so I'll make it 1.0, and I'll take one
sir,
case
your voice is
as.
breaking. Your voice is
Your
breaking.
voice is breaking.
Yes,
Yeah,
sir. Your voice is
that's what.
breaking in between.
Okay, is it fine now? Good. Is it okay?
Yes, sir.
Yes, sir.
Okay, fine. Okay. Hey, if you can, just a minute. I'll just wanted to see that question once again. Can you just tell me once?
Yes,
Can you
sir.
show
Yes,
me
sir.
the
The
screen so that?
probability
Yeah.
density function of a continuous random variable is given by fx 0.25.
From where this question is?
Sir, from
Active.
Activity
12.1.
question 12.1.
Okay. Okay, I think this question has some issues. Why I'm saying this is because this x is greater than or equal to 2 is written over there, right?
Yeah,
I think that has to be, it
it
shouldn't
is
be that.
confusing.
It should be 3.
Yeah,
Everywhere actually it
it
should be
should
3.
be. Yes,
Okay.
sir.
That's what actually I was also, okay. I think like a lot of issues are there with this question. Not lot, maybe that three is the issue, right?
Yeah.
Okay, otherwise I think
Sir, a
it's
similar kind of question is available also here. Like the second one, it is the same.
hmm.
I
But I
am
think
able
this is
to.
okay. This is okay.
Yes, sir. So,
Okay, the issue with that question is less than 3.
yes, sir. So
So
it should
or
be
greater
3,
than
right?
3. The all two the all two should be 3. It shouldn't be right.
Okay, sir.
And then that option D is correct only, right?
Yeah. Yes,
So
sir.
already we have found out. Yeah, that's all. Yeah.
So what is the issue in the question? Please tell.
That yeah, I'll tell you. So the thing is the options, right? There is no issue in the question. The options. So the answer should be like this, right? I know how to find f of x. It is actually I need to integrate from -1 to +3, right? F of x into dx, right? So which is nothing but -1 to +3 0.25 into x dx. So this should become 0.25x, right? From -1 to +3, and this is 1 by
Minus
4.
1 to x or 3.
Sorry, x. Okay, sorry, x. If I wanted to find the generalized formula, so this will become x plus 1, right? So this is like x plus 1 by 4, and this CDF will, so the CDF I'll write it like this. So it is 0 when x is less than or equals to -1. It is x plus 1 by 4 where x is between 3, between -1 and 3, and it is 1 when x is greater than or equals to 3. So in the options actually it is written as x is greater than or equals to 2. Okay, that is a wrong thing. So all the options are having that greater than or equals to
Which
2. It
question
should
is
be
this?
Sir, how we
actually,
got 1 for x greater than 3?
see if
Can
you
you explain again?
which part
Which
you will
question
doing?
is this?
I think this is activity questions. Activity questions 12.1. Can you tell? Like, I'm not sure. I forgot.
Sir, how
Question number
3 is
5.
replaced
Sir,
by
12.1. 12.1 question
x?
12.
number.
Okay, okay. 1
12.1.
minute. 1 minute. 12.1.
Question number 5.
Yeah, activity questions 12.1. Uh, question number 5.
5.
Okay, okay.
So please
And
explain how we got 1 for x
yeah,
greater than 3.
it is easier. So this is my generalized CDF formula, right?
Yes,
Correct.
sir.
So if I substitute uh, 3 here instead of x, what will happen? So f of 3 is what?
1.
3 plus 1 by 4, which is equals to 1, right? So for all values more than 3, I'll get 1, right? That is the okay. What is the range of CDF? It is from 0 to 1, right?
Okay,
Correct.
sir, -1 included in the second function or 0 for -1 0? Fx will be 0 for -1.
For less than or equals to -1,
But
right?
in the option it is given x less than -1.
That is okay. It's continuous when it is a continuous random variable, right? This inequality doesn't have any issues. So I can have x is less than -1. I can have here it. This is correct. This is also correct. This is also correct. This is also correct, right? This inequalities does not have any issues because in case of continuous random variables, you see you cannot find the probability at one point, right? It is equals to 0. We always find the probabilities where less than or equal to that point, right? Correct. In continuous random variables, if you know, generally let's say when I say f of 1, it is probability that x is less than or equals to 1. I cannot be able to find probability that x equals to 1. What is it? Probability that x equals to 1 is equals to 0, right? In case of a continuous random variable, it is always less than or equals to 1 or something, because the continuous random variable, the probabilities don't exist at fixed point. Actually we are finding the probabilities in some discrete or not discrete, I mean single piece of maybe I'm not sure, I'm not getting the word for it, but generally okay, I'll show you through the graph maybe. So suppose this is my slice, you can say, yes. So if this is my function f of x, and let's say this is a kind of a graph, and if I wanted to find probability that x less than or equals to 1, then I'll just integrate, like we'll get a slice and we'll integrate that slice over the range of that values. And if I do that, then I'll get two probabilities. So I will not get the probability exactly at this point, right? Because when I go to that point, it will become equal to 0, because there is no area involved in it. Generally, what is the probability for continuous random variable? Area under the curve, right? And when I say 1 point, then there is no area under that point, and hence the probabilities are equals to 0. Okay. So this inequalities does not have any issues. So if I have this kind of things, all are correct. Less than correct, less than or equals to correct, single side less than, like both the sides strictly greater than, strictly less than, does not have any issues. Okay. Okay.
So
Fine.
can I ask a question now?
Yes. Yeah.
So can I share the screen?
Okay, sure. Just a minute. Yes.
So I applied the same logic that we did like in the previous question that I asked, but I wasn't able to find it.
Okay, this is the conditional probability, right? Okay, it's a good question. So let x is exponential distributed, then find the value of z such that this equals to, okay, done. Okay, this you can stop
So
sharing. Yes.
can I like interrupt for a second? Like we did one conditional no, like exponential probability, like I asked before this one, right, sir? Like we applied the same logic, right, sir? But this time we used
Yes.
conditional
Yeah,
probability.
this is same logic, but I think you have missed that conditional probability part.
Like I have one more question about conditional probability. I think I can solve if I understand this one.
Okay, done, fine. So suppose x is what? X is distributed as exponential lambda, right?
Yes, sir.
Okay. This is okay?
Yes, sir.
Okay, so x is distributed like this, exponential lambda. And what we have given?
So
Condition, probability that
probability x is greater than 100, given that x is greater than 75 is equals to probability of x greater than z.
this
Greater and equals to in all cases, sir.
Okay, fine. I told you, right? For continuous cases, it does not have an issue.
Yes, sir. Yes,
okay,
sir.
Generally, okay, tell me now. First of all, you need to understand. Okay, first of all, what is the CDF of x?
So it's e to the power minus 100 lambda for 100 and e to the power minus 75 lambda for
Yeah, that is
70.
okay. No, generalized. So it is
Oh,
lambda.
yes,
Right?
generalized.
Okay. Tell me what is probability that A given B?
So a into a intersection b divided by p of p.
Okay. Okay. So let's say this is the event A. Okay, and this is the event B. How to find the probability that x is greater than 100 given x is greater than 75? So this is probability that x is greater than 100 intersection x is greater than 75 divided by probability that x is greater than 75. Okay, this is okay?
Yes, sir.
Okay, so I'll just write a number line, draw a number line maybe. So let's say this is x. Okay, so I'm here at 75 and I'm here at 100. Okay, what is x is greater than 100? Which portion?
100 and x.
Right side.
This was
100 to plus infinity.
Yeah, and which is the portion x greater than 75?
75
one?
to x.
Right. Okay, when I say intersection, what does that mean? Which portion?
100 to x.
Common
Right.
portion between two.
This is right. Correct.
Yes, sir.
So what is this portion?
It's just
X
100.
greater than 100.
X greater
X
than
greater
100.
than 100, right? Okay, this is okay. You're okay with this?
Yes, sir.
Okay, so I'm just removing this. Okay, so provided that x greater than 100, intersection x is greater than 75. What does that mean? That means probability that x greater than 100, and this is divided by probability that x is greater than 75. Okay, what is f of x? Is probability that x is less than x, right? Correct?
Yes, sir.
Got
Okay.
the answers. Got the answer, sir.
So okay, I'll just anyway I'll solve for others.
Yes.
So provided that x is greater than 100, I can write this as 1 minus probability that x is less than 100 divided by 1 minus probability x is less than 75. This is okay?
Yes.
All of you, are you with me?
Yes, sir.
Yes,
Okay,
sir.
so 1 minus probability that x is less than 100. This is what? This is nothing but f of 100, right?
100.
And this is f
F
of
of 75.
75. So I'll just write this as 1 minus e to the power minus 100 lambda, right?
Yes,
Yes,
sir.
sir.
Yes.
And so this will become actually plus e to the power,
Yes, sir.
right? And similarly, the denominator will become e to the power minus 75 lambda. Is it okay?
Yes, sir.
Okay. So here this will become, so e to the power minus 100 lambda minus or plus. This is okay?
Yes, sir.
All of you? Okay.
Yes, sir. Yes, sir.
Yes.
Okay. So this will become e to the power minus 25 lambda, right? Okay. This is my left hand side. What about right hand side? Right hand side is provided that z is what is
X greater than
Z?
Z.
No, not z. I think it is x is
X greater than Z, sir. X greater than Z.
huh.
Greater than or equal to.
So I can write, yeah, so I can write it as e to 1 minus e to the 1 minus probability that x is less
Sir,
than
1
z.
minus p of x less than 100 is f of 100 only, right?
Yes, correct. I've written here, no? Correct. So this is what?
Yes.
1 minus probability that x is less than z. This is nothing but 1 minus
E
this
to
is
the
f
power
of z.
minus lambda Z.
So this is e to the power minus lambda z. This
Z.
is my right hand side, right?
Right hand side.
And this was my left hand side. I can actually equate those. So it will become e to the power
So which question is
75
this, sir?
lambda, which is equals to compare it.
So which
So then what
question
will be
is
the value of z? This is a question from previous year question.
yes.
Sir, can I ask another question, sir?
Sir, can you explain again?
Okay. Give me a minute. Okay, so okay, I'll just explain it once again. Okay, the x is uniformly distributed, sorry, not exponentially distributed with parameter lambda. The condition is f of x is greater than 100 given that x is greater than 75 is equals to probability that x is greater than or equals to z, right? So this was my left hand side and this was my right hand side, right? Okay, and I know what is CDF. Who asked me this to repeat?
Sir, I asked for
What
repeating.
is, yeah, what is your name? So
Atharva.
Atharva, okay, just tell me, do you understand this or not? So what is CDF of x here? If it is exponentially distributed, it is 1 minus e to the power lambda x, correct?
Yes, sir.
And this is nothing but probability that x is less than or equals to x is okay. Is it okay, Atharva? Okay, are you there or no? Am I audible?
Yes, sir.
Yes, sir,
Yeah,
you are
okay.
audible.
Okay, fine. So this is probability that x is less than or equals to a. So how to, let's take the left hand side first. So left hand side, it is probability that x is greater than 100 given that x is greater than 75. This is a conditional probability. So by using the conditional probability formula, I can write probability that x is greater than 100 intersection x is greater than 75 divided by probability that x is greater than 75. Okay, and which is nothing but probability that x is greater than z, which I can write it as 1 minus probability that x is less than z. Okay, less than or equals to z. Okay, in this case, probability that x is greater than 100 intersection x is greater than 75. As I already told you, this should be probability x greater than 100, right? Divided by probability that x is greater than 75. So what is 1 minus probability x is, what is this? It is f of z, right? CDF of z, and that I can write as like this. So which is f of z is equals to 1 minus e to the power minus lambda into z. So if I do that, it will become 1 minus e to the power minus lambda z. So this side will become, so it will become plus e to the power minus lambda z. Okay, and what about this numerator? Is 1 minus probability that x is less than 100, less than or equals to 100 divided by 1 minus probability x is less than or equals to 75.
Yes, sir. Sir, your voice is not coming.
Hello.
Hello. Excuse me,
Yeah,
sir.
I'm audible, right?
Yes, sir. You are.
Okay.
So voice is too low, sir.
Okay. Is it fine?
Yes,
Yes,
sir.
sir.
Yes, sir, it is.
Sir, can you
Okay.
explain only last step?
Yeah. So this is what. Did you understand this one? This part, e to the power minus 100 lambda and e to the power minus 75 lambda.
Uh, no, sir.
Okay. Until this, where you stuck? This is okay. Provided that x is greater than 100. Provided that x is greater than 100, can I write it as 1 minus probability that x is less than 100? I can write, right?
Sir, is it clear? That point is clear.
So what? Okay, what is this then? 1 minus what is provided that x is less than 100? Hmm? Is CDF, right?
Yes.
So this CDF should be like this, right? 1 minus e to the power minus lambda, and x value is 100. Small x is 100 here. So this should be equals to 1 minus e to the power minus lambda 100 or 100 lambda. Okay. And if I solve it, 1 minus 1 plus e to the power minus 100 lambda, and this one will get cancelled. So I'll remain with e to the power minus 100 lambda. Similarly, this is true for provided that x is greater than 75 denominator, and denominator will become e to the power minus 75 lambda. This is okay?
Yes, sir. Last step.
So last step will be here. So this is e to the power minus 100 lambda divided by e to the power minus 75 lambda. So what is e to the power a upon e to the power b? It is e to the power a minus b. Okay.
Okay. Got it.
So this will become 75 lambda. So this is nothing but e to the power minus 25 lambda, and which is equals to e to the power minus lambda z. And to both these quantities have to be equal. What is it? My z value should be equals to what? 25, right? Then only this two will be equal, right?
Excuse me, sir.
Yes.
Sir, I have a doubt in
Sir.
One
week
minute.
11.
Just a minute.
Can I
Somebody
ask?
else. No, 1 minute. Just somebody else speaking. No.
Yes,
Just
sir.
let him.
Sir,
Yeah.
sir, I just joined late. Sir,
Yeah.
are you discussing the concepts or you are taking the doubts?
No, I'm just taking the doubts, whatever is there, like from anywhere, like it's fine.
Sir, in the ma'am, when ma'am was taking the session, she also, I have just a small doubt on that additional content. Did you tell about that, or I can ask?
Yeah, I'll tell you. So the additional content, so that additional content, I think it contains a normal distribution. So you need not to go through the normal distribution. Okay. So the questions will not be asked from the additional content. Fine. I think you guys have got the notification regarding that also.
Yes, sir. We got the mail, but actually we were confused about that. So ma'am thought about and
Correct. So she has actually taken all the things, whatever is there. Anyway, normal distribution is important for the statistics too. So whenever you're entering into the stats 2 course, that is anyway important. But don't worry, the end term exam will not contain any question from normal distribution.
sir,
Okay.
all the contents from additional content, all the
all the content from additional content will not be there.
okay, sir. Thank you, sir.
Okay.
So can you please explain the topic of circular permutation?
Okay, circular permutation.
Sir,
So
I
I'll
have
not.
a question.
Okay. First of all, okay, I'll just talk about circular permutation first. Uh, what is circular permutation is that it's not actually very difficult. I'm not going into details of the what is the concept or how these things
So
work.
please take an example or a question.
You just tell me the question, no? Then I'll just maybe solve that question. If you have any question, just search for the question and then let me know.
Sir, can I ask my question in the meantime, sir? Can I share it?
Yes, please. Yes, please. Yeah. Are you going to share the screen, or you want to tell me the
Yes, I want to share the screen,
question?
sir.
Okay, just let me stop my screen first then.
Sir, can you see the screen?
It's not visible yet, but yeah, now it's visible.
So yes, this one, sir.
Okay, the duration of a video game is a random variable with an exponential distribution with mean 20 minutes. Suppose that if when you enter a video arcade, two players are playing the game. Find a probability that exactly one of the two will be playing for more than 40 minutes. Fine, it's a good question. Okay, you can stop the sharing, then I'll share my screen.
Excuse me, sir.
Yes.
So these questions, I think they are also part of mock which has been released.
Oh, okay, fine. Anyway, we have one session again on this Thursday, right? On mock discussion. So I can skip the question if I already taken this today. That is okay. Or if you have any doubt again, I'll just explain it there. Okay. That is okay, right?
Okay, sir.
Okay. So the x is the random variable which is exponential, and what is 20 minutes here?
I think it's lambda, sir.
No, it's
It's
average time, right?
average, so maybe
So
lambda.
Expectations, sir.
1
yeah,
by lambda.
yeah. So this is expectation of x, which is 20. And what is expectation of a exponential distribution?
1 by lambda.
1 by lambda. So lambda will be
Lambda
equals to what?
20.
1 by 20.
Sorry, 1 by 20.
Okay. So this is exponential 1 by 20. And now the question is, uh, if the two players are playing in that video arcade, and what is the question? At least one of the player has to play more than 40, right? It's kind of like that, right?
So yes, more than 40 minutes. Exactly one, not at least.
Exactly one, or at least exactly one.
Exactly one, sir.
Okay, so let's say there are A and B. These are the two players. So exactly one means either A will uh, just a minute. I just uh, one just a moment. I'll just stop 2 minutes and I'll just come. Okay. Am I audible now?
Yes,
The
sir.
voice is breaking,
Hello.
sir.
Okay. Is it okay now?
It's
Yes.
fine. It's fine.
Okay, done. So exactly one player means what? Either A will play more than 40 or B will play more than 40, right? Is it correct?
Yes, sir.
Okay. So let's say A will play, let's say, more than 40, then B will play less than 40, correct?
Yes, sir.
Or A will play less than 40 and B will play more than 40. This is okay?
Yes, sir.
Okay. So let's say, and both of them are actually exponentially distributed. So in that case, I'll say A greater than 40 and B less than 40 is what? Probability that X greater than 40 and probability that X less than 40, right? Or
Yes.
again, this is probability that X is less than 40 and probability that X is greater than 40. So I can just actually multiply by 2, right? To one of this, because both of them are identical anyway or same. So it is greater than 40 and probability that X is less than 40. Okay. What is this correct? This okay? Why I wrote like 2 times? Okay. What is probability that X is greater than 40? It is 1 minus
minus.
probability that X is less than 40, and I know that it should be equals to e to the power minus 40 lambda. Lambda is 20, right?
Yes, sir.
Okay. And what about this? It is
1
1
minus
minus
power minus 20
e to the
x
power
into.
minus 40 by 20, right? So this is nothing but 2 into to the power minus 2 into 1 minus e to the power minus 2. Okay, until this point is okay?
Yes, understood, sir. So that's the answer.
Okay, this is the answer. This is the final answer. Or
Yes,
we have
yes,
like okay.
yes. It's, so can I ask another one, sir?
Yes.
So
All of
can
you
I?
are okay with this, right?
Yes, sir.
Okay. Fine.
I have b less than 40 plus a less than 40.
So I just showed that a less than 40 and b less than 40 to to understand. Generally, it should be x is greater than 40 or and that.
If sir, if there is given 3 players are playing independently,
Okay.
what will be?
Okay. Then depends on the condition. If the condition is same, then you tell me what should be the case. Then a should be like one instance will be a is greater than 40, b less than 40, c is less than 40, plus a less than 40, b greater than 40, and uh, c less than 40, right? And plus like that. If it is said exactly, if in this case, let's say these two players are playing, and if in this case you let's say I asked you the question as at least one. In that case, how will you add the probabilities, or what will be the cases?
1 minus p is equal to 0.
Okay, that is one idea, right? That is okay, fine. So it's not b equals to 0. It should be like provided that x is less than 40, right?
Yes, yes.
Yeah. And if you don't understand that, so what will be the cases? A greater than 40, b less than 40, plus a less than 40, b greater than 40, plus a greater than 40, b greater than 40.
Yeah, so we are using like Bernoulli trials with exponential. Like we are combining both the concepts in some way, right? So like we are bringing in Bernoulli trials like in this, like a concept of it.
Bernoulli trials, okay. How it could be Bernoulli trials?
So we did A is greater than 40 and B is less than 40, right? So it's like the possibility of a success of A and failure of B. And in the other and in the next option we took success of B and failure of A. So it's not exactly Bernoulli, but we are bringing it in some way or the other, right?
Okay, you can, but it should not. I should not say it's correct only, right? So
Yes,
it's
sir.
not
What you have told about in the previous question, at least what you have said, what will be the case, or at least?
So at least if say at least one player will play more than 40, what does that mean? Either A will play more than 40, and B, then in that case B will be, and B will be less than 40, right? This is one, plus
One case.
A less than 40, B greater than 40, plus A is greater than 40 and B is
B is
greater than
good.
40. Done, right?
Okay.
Or
Okay,
in that,
three
and,
case.
yeah, and in opposite of it is what? 1 minus A less than 40, B less than 40. Right?
Yes. Okay. Okay.
So can I share that?
This is like you guys have, yeah, I just said you guys have studied that permutation combination, right? Or probabilities there. You can actually play the same thing here. It's not the different case actually. Okay. Okay. So the question is probability mass function of a random variable is given as this. Based on the given, what is the value of k? I think it's very simple one. What I feel. Okay.
Yes,
This is the
sir.
question.
Simple, but I did not understand. I did not get that.
Okay, fine. This is a discrete random variable. You understand, right? Anyway, the question says itself. It's
Yes,
probability mass function. When it said probability mass function, then definitely. Okay, you can stop sharing your screen. I'll just share my screen. Okay, so this question you guys have to answer. Okay. Okay. So probability that x equals to x. This is a PMF given, and what is it? It's k into x, where x takes values 1, 2, 3, and 4, and it's 0 otherwise. Okay. So let's say if I wanted to draw PMF table here, how will I draw this? So x, and probability that x equals to small x. So x will take which values? 1,
1, 2, 3, 4.
2, 3, 4. And what are the probabilities associated with it?
K, 2K, 3K, 4K.
K, 2K, 3K, and 4K. And what
It
is
will
our
be sum up to 1.
what are the properties of probability mass function? The sum
K
of
plus
all the
3K.
probabilities should be equals to 1. So if I
1.
just add K plus 2K plus 3K plus 4K is equals to 1.
10K.
So 10K is equals to 1 and K equals to 1 by 10, which is nothing but
0.1.
Understood. Understood. I understood. I understood. Sir.
Okay.
Understood.
Done.
So one more question, sir. It's about permutation and combination. Can I ask
Yes.
about?
Yeah. Tell me. So today I'm just going to solve the questions. I don't have anything to discuss.
Sir, can I share my screen, sir?
Maybe if that is simple question, you just tell me and I'll write it down.
All right, sir. So 6-letter words with or without meaning are made using the letters of the word S, A, C, H, I, and Sachin.
Okay.
Yes.
Sir,
So
please take a snip of that question and put in the chat box. We will also.
Okay.
Yeah, maybe you can share the screen itself. It's better.
That's right.
Yeah, because the way you are reading it.
Yes, sir. My bad, sir.
Okay. So 6-letter words with or without meaning are made using the letters of the word Sachin. Okay. If all the formed words are now arranged in ascending order, then find the serial number at which the word Sachin will appear. Okay, fine. So this is kind of a dictionary type of problem. So how will you go through the dictionary? It's according to that. Okay. So actually it's a dictionary problem, but the way it is formulated, it's not good, I guess. If all the formed words are now arranged in ascending order. Okay, fine. So just you can stop the screen. I'll just tell you the answer. Maybe not. This is not a good formulated question. Maybe. Okay. So there are this searching, right? How many words are there? Oh, sorry. How many letters are there in the word searching? 6.
5, I guess. S, A, C, H, I.
6, sir.
6, yes.
So how many words it can actually it can form from the 6 letters? 6 factorial, right? 6 factorial, because these are 6 are the distinct letters, and with these distinct letters I can form 6 factorial, or there are 6 factorial ways in which I can have these words.
Sir, please explain the question.
Am I not sharing? Am I not sharing?
Not sharing, sir.
Okay.
Sir, what is the meaning of serial number? It is from dictionary type. In dictionary.
Yeah, it's kind of a dictionary. Yeah, it's kind of a dictionary. For example,
Okay.
I started with A, then I started with the next
C.
letter
A, C.
C, like this. And then at what point or at what serial number that Sachin will come? That is the question. It's badly formed question, maybe I'll say, but it's fine. So there are total of 6 factorial ways, right? So correct. So or maybe 6 factorial words can be formed by using this letter 6, this 6 letter. So with A, how many?
Which question is this?
This some previous year question. I don't know like which question, which year it was asked, but it is a previous year or previous term questions. Fine. Okay. So let's say this is if I start the word with letter A. So how many remaining positions are there? 1, 2, 3, 4, 5. And these 5 positions can be formed in how many ways? So 5 factorial, right? So total number of words it can form is 120.
120.
Is it correct? 5 into 4 is 20. 20 into 3 is 60. 60 into 20 is 120, right? So the next,
So can you share the question, sir? One.
Okay. So who has asked me this question? Can you just take a screenshot and paste it in the chat?
Yes, sir. Sure, sir.
Yeah, please. Okay. So in this case, okay. So I'll start with letter A, and what will be the last word of this when I start with this A? Can you guess it?
S.
Okay. So maybe in this case SAN or okay OPQR. Okay, yes, I think AS N. I guess it is I, H, and C. Is it correct? Is it
Yes.
correct?
Yes,
This
sir.
is 120th word, right? This is 120th word. Okay. So I'll say it is 120th word. Okay, fine. But I'm not worried about this. I wanted this word SSHIN. So the next one will be what? I have to start with which letter?
C.
C. So there are again 5 factorial ways. It is 120. Okay. Then I'll start with what?
H.
H.
Sir.
Oh,
H.
yes, sir.
H will again 120. When I start with I, it will be again 120. Is okay? Okay. Then I'll
Yes.
start with what?
N.
And N will be again 5 factorial ways. It is 120. And then I'll start with S.
S.
Okay. Okay. If I start with S, so until now, how many words are formed? 120 plus 120, 240 plus 120, 360 plus 120 is 480 and 480 plus
600.
120 is 600. Okay, 600 and first word will be what? S, A,
SAHIN.
C, H, I, N. Is that correct?
Yes, sir. Correct. Sir.
And this
Yes.
is which word?
So 600.
600 and first word.
Yeah.
So, but for example, if we had to like get something else like SHIN, like jumbled up word instead of Sachin, but like jumbled up.
Then you have to think about like this, right? So it's difficult because this problem will become difficult. Then let's say I say something like the SCAHIN, something like this. In that case, what you will do? So I know until 600 it is here. Okay. Then I'll start with S. Okay. Then I'll think about because I wanted so let's say this A, H, I, N are in ascending order, right? Like uh, are in the same order. So I'll just think about this two. With this two, and okay.
I think
First
SA sir, first. I think SA, sir.
first SA. So with SA, how many words can be formed? It's again 4 factorial, right? It is like how much it is? 4 into 3 is 12, 12 into
yes, sir. Yes,
24,
sir.
something like 24, right? And then I'll go with SC, and then I'll see which word it is. So it is 625th.
Yes, got it, sir. So we keep fixating words and like assert,
Yeah.
like give them positions and like
Yeah.
calculate one by one. I got it, sir. Got the concept, sir. Thank you, sir.
Right? Okay. Any other questions?
Sir, I have sent the question in chat box.
Which one? The same one or the different one?
Other one, sir. 3 cards are drawn.
Okay, let's check. Fine. The three cards are drawn from an ordinary pack of 52 cards. Find a probability that exactly 2 are ace cards. Okay, it's you have to tell me. Okay, you just have to guide me. So there are how many cards in the pack?
52.
52. Okay, how many aces are there in 52 cards?
Four aces.
Right. So I'll say in 52 cards we have 4 aces. The question is find a probability that exactly
2 are ace cards.
find a probability that exactly 2 are ace cards. And how many cards we have drawn? 3
Three
cards, right?
cards are
We have
drawn.
drawn 3 cards. Okay. So if 4 are aces, then out of 52, how many are the other cards? 48 other cards, right?
48. Yes.
Other cards. Okay. So what is probability? I want to find probability that, let's say, x equals to 2. Okay. What is the general rule of probability or general formula of probability? It is favorable outcome
by total
upon
outcome.
total outcomes. So if I pick 3 cards out of it, what is the total outcome? Total number of ways in which I can draw 3 cards out from the 52 cards is, what is it?
52 choose 3.
C3. What is favorable? Favorable should be, let's say, 2 cards which should be ace. So exactly 2 means 4 C2, right? And the remaining one card will be coming from where?
48.
So it is
8
48
cards.
C
1.
So the probability
Okay.
should be equals to 4 C2 into 48 C1
48
divided by,
C1 up 52 C3.
that is your answer. This fine?
Yes, sir.
So I'll ask one follow-up questions to all of you. Let's say this question, the same question is there. The only thing is I wanted to find the probability that at least 2 cards should be aces. What will be the answer now?
We find the like 0 and 1, like the probability of 0 aces and 1 aces, and like 1 minus the addition of 0 and 1.
You can do that way, or I can do this way also, right? Like
4
4C2,
2.
42C1, or 4C3.
3 cards.
Sir, what is your question?
At least 2 cards should be aces. The same setup is there. There are 52 ordinary pack of cards, and then I have drawn 3 cards randomly out of this 52. I wanted to find a probability that at least 2 of the 3 drawn cards are aces. So this should be the answer, right?
Yes, sir.
Yes.
At least 2 cards are aces out of the 3 cards drawn randomly, right? Okay, done.
So can I ask my questions?
At most 2 cards.
Sir, can you please share the question?
Question is there in chat box. I do not have any questions. I'm just taking the questions from you guys and I'm just explaining it.
Sir, can I ask my question, sir? If you are
Yes,
done with
please. Yes, please. Yeah.
Sir, can I share my screen, sir, for this one?
Okay. Just give me a minute. I'll just have a drink. Like I'll drink water and I'll come back. Huh? Just give me 2 minutes. Until that time, you just share your screen.
Sir, please share the previous question snip. I just take a snip of that question.
Previous is there, no, in chat box. The 2 cards drawn, right?
No, sir.
Three cards drawn.
Your solution from just previous one.
Okay. Previous one means for which question? The 3 cards?
Yes, sir. You have just taken at least part.
Okay. That is okay.
Okay, sir. Thank you. Take a break.
Okay, so okay, let's say, is it fine? Okay, somebody was sharing the screen. You can share the screen now.
Sir, can you see the screen, sir? Sir,
Suppose
questions. I just wanted to explain how I did it, sir. So, like for this one, sir.
Okay, first of all, tell which one?
And so this one, sir. So for this one, sir. So like for P of A, right, sir? I have found P of A and P of B both, and I've got the answer, right, sir? But I don't like I multiplied P of A and P of B to get the answer, right, sir?
Okay, I don't know. Right is not the problem.
Yes,
Okay.
so I got it. I got the right answer, sir. But I did not understand why we are multiplying, sir, in and, sir.
Okay,
Like,
sir, please
first of
explain this question from scratch, sir.
Yeah, I'll do. Just what? I'll just see what is the question. Suppose
so
okay,
this is
you are moving a lot actually. You just don't move.
Sorry, sir.
Yeah. So
This is
suppose that just I'll read the question first and okay. I think you are moved. Okay, that is the question and what do you say? That what is that? The other one? These two are the sub questions.
the sub question, sir. This one I did not understand, sir. This one.
The second one. Fine.
Yeah.
Just show me the first one. We'll discuss the second one. Both the questions we'll discuss. Okay. So the question is, suppose that 30% of the regulators are defective in each line A and B. Okay. What is the probability that exactly 3 of the 5 regulators from line A are defective and exactly 1 of the 5 regulators are B are defective? Okay. First of all, tell me what is probability of, let's say I'll say defective. Defective is my success. In that case, what is probability of A?
It's 0.1323.
No.
Probability of A 5C3 into 0.3.
0.3, right? 0.3, right? Okay. So let's say, okay, I'll put it in this way. Let's say probability of having a defective in line A is 0.3, right? Okay, I'll just write it down. Just stop sharing your screen. I'll just write it down. So we know that 30% of the regulators on each line A and B are defective, right? This is the thing, right? I haven't shared. Okay, sorry. This correct? Are you able to see my screen now?
Yes, sir, we can.
Yes, sir.
Okay. So we have given that 30% of the regulators on each line A and B are defective. So let's say D is the event which says the regulators are defective. Okay. So okay, so I know that okay, how to put it in this way. And what is it given? Like 3 of the 5 regulators are defective, right? Regulators are defective in A and what is it? The second statement is what?
1 out of 5, sir.
1 out of 5 are defective in B and what we have to calculate?
So the probability. Wait a second, sir. What is the probability that exactly 3 of the 5 regulators from E are defective and exactly 1 of the 5 regulators from B is defective?
Okay. Okay. So probability that a regulator is defective and given that it is coming from assembly line A is how much? It is 0.3, right? Right? And similarly, that probability of the regulator is defective, given that it is coming from B, it is also equals to 0.3. This is correct, right? This is understandable, and this is coming from the first statement itself, right?
Yes, I did.
All of you agree with this? All of you are okay with this?
Yes, sir.
Okay.
Yes, sir.
Okay. So I wanted to find that 3 of the 5 regulators coming from A are defective, and one of the exactly one from the 5 out of the 5 regulators coming from B are defective. Okay. Then I need to just, so it's okay. I think we can actually directly do it like but okay, I'm not sure like how to find it again. So I need to find the probability that and the question is probability that 3 out of the 5 regulators are coming from A, and is it written and or what is it written there? Can you just read it once again, the line?
Sir, the probability of both happening, and sir, 3 of 5 and 1 of.
Okay. Okay, that. So let's say 3 will be coming from this. So let's say there are 5 regulators which are coming from A, right? So what is the probability that uh, 3 of 5 uh, are defective in case of A?
5C3 into 0.3 to the power 3 and 0.7 to the power 2.
Okay, that case also, in that way also I can do right. Actually I can do in other way also. Like we can just take the proportion and we can just multiply with it. But okay, this is the case, right? So generally what should I do? Like it should be 5C3, right? And 0.3 to the power 0.3 to the power 3 into 0.7 to the power 2, right? And what about the second case? It is 5C1
1.
and 0.3 to the power 4 into 1 and
So 1, sir.
yeah. So if you just calculate, tell me, is it correct answer or not?
Yes, it exactly comes to be 0.049, sir. So
Yes.
one doubt, can you clear my doubt? One doubt, so like the concept, not even a doubt. So
Hmm.
like, why are we multiplying both the probabilities when it's and, sir, and what we do when it's or, sir? Like, in or do we
So
like add them?
okay, so that is actually basically it again comes from where the basics of permutations and combination, right? The addition principle
Yes.
and the multiplication principle. So when you say, let's say, so suppose if you say or means you have either you can do this or you can do that. So you cannot multiply these two probabilities, right? Because you have the choices that okay, this one event, either this event can be happening or that event can be happening. So intersection of the events is not possible at that point, right?
So this is a Poisson distribution, no?
Poisson. Okay, how can it be Poisson distribution? Poisson distribution is the number of events occurring in the fixed time frame or in the fixed space, right? I don't think it's a Poisson distribution.
So it is Bernoulli.
It can be, I can model it as a binomial random variable, but it should be like two binomials, right? One for A and one for B, right? It's correct.
Okay. Yes.
So I can say this is one binomial random variable, right? And this is another binomial. And
Sir,
actually
how
we are
we have
actually
to identify whether we have to use binomial distribution here? 5,
so
3,
it's
3.
so that's what I told you, right? There are total of how many regulators are there? We have chosen from for A 5, right? For A it was 5, for B it was 5, right? And what I did is I wanted 3 out of 5 defectives, correct?
Yes.
So 3 defectives can be like anywhere, right? In this 5. So how to find these three defective, and each of the whatever, I don't know what is it, is it a bulb or what? Let's say it is a bulb. So let's say if the first bulb
Regulators.
yeah, okay, regulator. So if the first regulator, if it is defective or not, what is the probability? If it is defective, the probability is 0.3, and not defective, it is 0.7. So it's Bernoulli trial, right? It's a Bernoulli trial. So we are just doing it for how many times? 5 times. If I do for fixed number of times, then like if this will become what? Binomial, random variable, right?
Binomial.
Binomial, right? Because binomial is what? If you
Bernoulli, but we repeat
So
it
can
some
you explain
number
from
of
the
times.
beginning? Show the question.
Question is there if I think I don't know, like, what is your name? You just paste your question in the chat box so that others can understand it.
Sir, I think some of his previous questions are already solved in the TA session, sir. Maybe you can. Yeah.
Sir, can you continue explaining about the and or of probability, like the basics of those?
Sir, I have a doubt. Not a doubt, it's a confusion. Sir, the question I have asked previously about CDF. So, sir, in that question, while differentiating in that integration, I have a doubt. Like we integrated, it is given like -1 to x range from -1 to 3, and its value is 0.25. So on integrating it, cannot we get it 0.25x?
0.25x.
So cause 0.25 is a constant, right?
Right. So I don't know where it was. I'm not sure. Okay, that question. This one.
Yes, sir. So, sir, while integrating 0.25, shall not we get it is like 0.25x rather the place of x plus 1 by 4. So why are we getting x plus 1 by 4?
Your voice are not audible.
For you.
Sorry, your voice was breaking.
Here we are integrating
So
from
let's say this is
-1
f
to
of x, right? And this is 0.25 dx. Okay, whatever the limits are, I don't have. There is no importance currently. Just tell you what is the integration of this part.
Sir. Yes, sir. Why that it should not be 3 at the place of x? Hello.
Okay. You are saying, okay. You have the problem with the integration output, or you have the problem with the limits?
No, sir. Like also limit and output is the main problem.
Okay, tell me now. Then so, okay, what do you think? Like, what is the integration of general? Okay, leave the limits. What is the integration of this 0.25 dx?
It should be 0.25x.
Okay, 0.25x, correct. So I can write this as 0.25x, correct? It's okay. And if I put the limit from -1 to x, how should I put it? This should be like this.
Yes, sir.
Okay, done. The next step will be.
It will be 0.25x.
Can I write this 0.25 as 1 by 4?
Yes, sir.
Okay, let's say if I put, okay, so I'll say x by 4.
X by 4 minus 1 by 3. Okay,
Is
so
okay, right?
we just open it up. Okay, sir.
So what will happen then? X by 4 minus
x minus 1 by 4.
Minus 1 by 4. So this is x plus 1 by 4. Same thing, right?
Yeah. So, sir,
So actually,
Yeah.
So okay, so the thing is, I can write, look, I'll say that if cx, or maybe I'll say if this c is a constant, right, the integration of c into dx is c into x. Okay, so I can actually do this integration by like this. So I can just take the constant outside and I'll just write down this. So this becomes again cx. The same thing I've done here. I've just taken this constant out 0.25 and I just integrated the other thing. Okay.
Okay, sir. Okay, thank
So
you.
both the things are same.
Yes, sir. Any important topic for editing?
These are all important. Whatever we have discussed anyway. This is no other,
So,
like I can.
like explain like the and or of probability, like
Yeah.
when do we
So
multiply?
and okay. Generally, what is and? So why we are multiplying the probabilities is, so okay. So I'll just go through the Venn diagram maybe. Okay. So let's say these are two events A and B. Okay. Suppose probability of happening an event is point. I'm not sure, like 4, let's say, and probability of happening event B is 0.6 or something. Okay. Let's say I'll say that either probability of A will happen or probability of or maybe or I'll say if let's say either event A will happen or B will happen. Then what should I do? What will happen to the probabilities?
So we add.
I will add the probabilities. Why I'll add? Because
Because both are
that
happening. So
yeah. So that means A also will occur. So what will A or B will include? It will include that event A alone will happen and B will not happen, right? Or A will not happen, B will happen, or both A and B will happen, right? This is okay.
yes, sir. Yes, sir.
This will all include. So let's say what is this portion?
A complement, sir.
So this is no. So this is A. This actually it's B complement, right?
B complement, sir. B complement.
B complement. Right? What does it mean? That means A will happen and B will not happen, right? Okay. This is
A complement, sir.
A complement, or what does that mean? A will happen, but sorry, B will happen, but A will not happen. And this portion is, let's say this is both A and B will happen. So this is all the things, right? So what is 0.4? Okay, if I I'm not sure, like I don't know like how to explain this, but this intersection of the events, right? Intersection of the events, when I just multiply these probabilities, it's 0.4 into 0.6, then this will become this portion. Okay, this will become, let's say, 0.24 something, right? And if I add all these probabilities, A or B, what will happen? That's 0.4 plus 0.6 will become equals to 1. So I can directly write probability of A plus probability of B. But okay, in this case, okay, when I say 0.4 and 0.6, in this case, the intersection was not there, right? So the correct diagram for this should be like this. They are disjoint events, right?
Yes, sir. Yes, sir.
This 0.4 and this 0.6. So they will become the this events when this intersection. The intersection means the multiplication of the probabilities will also include into that portion, right? And okay, maybe okay, but I think we have we have gone through like somewhere else. Maybe okay. The question is, why should I use and why should I use, or why should I multiply the probabilities when I use and why should I
Yes, a better way to put it out would be like
probability.
where to multiply and where to add when and on or like when should I multiply and when should I add when the wording is and or.
Okay, that if that is the case, then when there is and in the problem, let's say uh, A and B will happen. Let's say both. Let's say in this case, like 5 regulators, like two of the 5 regulators of A are defective, and 3 of the 5 regulators of B are defective. defective. When I say and in this case, then you have to multiply the probabilities of, so event 2 of the 5 regulators of line A are defective, this is one event, right? And 3 of the 5 regulators of line B are defective, this is another event. So when I say what is the probability that these two events are occurring simultaneously, and simultaneously in that case I'll say and. So 2 of the 3 regulators of line A are defective, and 3 of the 5 regulators of line B are defective. In that case, I'll use multiplication of the probabilities. Or when I'll say is, let's say I'll say, what is the probability that uh, either 2 of the 5 regulators of A are defective, or 3 of the 5 regulators of B are defective. In that case, what will happen when I say 2 of the either or, right? In that case, I'm finding the probabilities of 2 regulators which are defective in A plus 3 regulators which are defective in B plus this two happening, this two, right? Like 2 of the 5.
Oh, yes, sir. We are using the basic formula P of intersection and union formula, right,
Yes,
sir?
yes, that is a formula. Yeah. So
No,
this
understood,
basic formula
sir.
will use.
I got it. I got it, sir.
Okay.
Understood, sir. Thank
So
you, sir. I understood.
maybe understand, right? Like okay.
Yes, sir. A union B is equals to P of
Yeah,
A plus B plus
exactly.
A intersection B, right, sir?
Yeah. So I can say like this. So this will actually turn out to be, yeah. In section B, I can actually like write down like this: number of elements of A union B is equals to number of elements of A plus number of elements of
So will you be taking more doubts, or
Sir, if
I have another question
there,
section B, and when I divided by total number of. If you have any question, just like I'll finish the session by
sir, I have a
8:30.
question in same which you taken. How to
Ah.
calculate a B complement?
AB complement means?
Means can you scroll up?
Huh.
A
Okay,
B
what?
complement plus.
Okay, this is not the, okay, I sorry. So this is not AB complement means what? Actually, I was saying that event A is happening and B is not happening, right?
Yes.
That is what I mean. So
Yes. Yes.
which portion is this? This one,
Yes.
right? The red colored one, right?
Yes.
Where A is
Sir,
happening but B is
if
not happening,
there
right?
is A event is happening and B is not happening, so
That is only B
probability.
complement of
Yes.
B
Yes.
complement. That is it.
Yes.
Probability of B complement, right?
So that's probability will be A, which A's probability, na?
A's probability, but excluding this intersection, right? This
Okay.
green color area, right?
Okay.
Correct?
Okay. Okay.
Right now? Okay.
Sir, I have a small question. In can you take
Yeah, please tell me. Yeah.
week 11, 11.5?
Now, if you can tell me the question, it will be good. Like if you can read the question, it will be good.
Right, sir. So there are two questions, 7th and 8th. Week
Tell me then.
11.
Yeah. Tell me the questions. Tell me the questions. Read out the questions.
Suppose an uncontained marble of two different color, red and yellow. A marble is drawn randomly from the urn and its color has been recorded. Then marble is kept in the urn remixed before the next draw. Suppose the proportion of yellow and red marble is in the urn is pi 1 and pi 2. Let the urn has 15 marble. Out of 6 are red and a total of 10 marble is drawn from the urn in the stated manner based on given information. Answer the question 7 and 8.
Okay. So first of all, you said there are total of 6 red marbles, right?
Yes.
Okay, and the proportion is like R by Y is pi1 divided by pi2.
Actually, there are 15 marbles in urn.
Okay.
6 are
So
red.
15, and then that
Yes.
means 9 are yellow, right? Okay.
Okay, which
Yes.
question is this activity? 12 point. Yeah.
11.5.
11. I think
11.
this question I have solved on maybe like I don't know. I solved maybe Friday or something. I'm not sure. Okay, anyway, I'll solve it again. Next one is, so I know that red. So there are 6 red marbles, 9 yellow marbles. I have drawn 10 marbles randomly, and this
Yes.
is without replacement, right? This problem is without replacement.
Yes.
Okay, pi1 and pi2 are the proportion. Okay.
Yes.
Pi1 is what? Which proportion? Red proportion, no?
No, there is no. Suppose the proportion of yellow and red marble is yes. Pi 1 is yellow and pi 2 is red.
What is it? Proportions, no?
Yes.
Okay. Okay. And what is questions?
Calculate the value of pi 1 and pi 2 only.
Okay. So what is pi1? Pi1 is the proportion of red marbles.
Yes.
So it is 6 by 15.
0.
And pi2 is 9 by 15.
Yes.
So it is 0.4 and it is 0.6.
Okay. Okay.
Right? That should be
Yes.
the answer. The proportion is what? How many red marbles are there in out of the total marbles? So total of 15 marbles are there, out of which 6 are red. So the proportion that pi1 is equals to pi1 is the red marble proportion, and that is equals to 6 by 15, which is 0.4. Similarly, the proportion of the second urn is like, or the pi2 is what? The proportion of yellow marbles,
Yes.
which is nothing but 9 by 15. So there are total of 9 yellow marbles in that urn out of the 15. So the proportion is 9 by 15, which is 0.6. What is the 8th question?
Find the standard deviation of number of yellow ball.
Okay. So and then there are 10 marbles we are drawing randomly, right?
Yes.
Okay. And find the, what is the question? Find the variance, standard deviation. Okay.
Standard deviation.
Fine. So let's say this is a problem of which distribution?
11.5.
Yeah. No. Okay. That question is what? I think I discussed this one, right? Like I told you guys that this shouldn't be the correct answer because that problem was solved by using the hypergeometric distribution, right?
Okay.
Hypergeometric distribution, where, but the problem I had was x will take which values. So if I draw 10 marbles randomly, and if that is yellow, in that case it should becomes 0 1, the range should become 0 1 2 3 4 and up to 9, right? But
Yes.
to have this random variable x as hypergeometric, this should be equal, so we should have 10 here, but 10 is not possible since we have only 9 yellow balls. So that's
Yes.
why I said to you guys that I will just, okay, I forgot to consult with my colleagues this question. So maybe this question I will take on the Thursday session, right?
Okay,
I
sir.
just
No.
need a clarification on this question because I am not sure that this question should be solved by using the hypergeometric. We can solve it by normally finding out the PMF for this, and we can solve it because it's easier for me to find the PMF, but then the calculation will be difficult. Right?
Okay, sir.
I will talk
Forward.
to you. I will take this question in the next session,
How
Thursday.
to
Okay.
solve using PM, sir?
Sir, how long is this
PMF.
class? So sorry to interrupt.
No, I'll just finish it in like 5 minutes. That's it.
Sir, how to solve
Whatever
using
doubts will be
PMF?
there.
PMF.
Yes,
Yeah,
sir. Yes.
so this is not difficult. See, they're getting 0 yellow balls. What is the probability? So it should be 9C0, right? And 6C1 divided by sorry, not this one. So we are taking 10 balls randomly, right? We are choosing 10 balls randomly. In that case, Actually, see, again, the problem happens here is I cannot have 0 here, right? I should start with 4, right? Because if I choose, let's say 6C, 6 also, if I choose all 6 red balls, then in that case, I will get anyway, how many yellow balls? 4. Is it correct?
Yes, sir.
Right. So my range of X should start from 4 yellow balls, then 5 yellow balls, 6 yellow balls, 7 yellow balls, 8 yellow balls, and 9 yellow balls. And why it is 9? Because 9 is the maximum that we can reach there. Right. So the probability that X equals to 4 is this. Probability that X equals to 5 is uh, let's say 6C.
For you.
Can you please just reduce the volume of the TV? Yeah, so it's 65 into 9C5, right? Here, and divided by 15C10. Similarly, here it is 66, sorry, 64 into, it should be 9C6 divided by 15C10, like this. You can have the PMF like this, and then I can find the expectation of that PMF, and then we can find the variance. But again, those calculations will be.
Why X can
Sir,
take value 4,
we
5,
need
6,
to
7, 8,
add
9?
these all.
Okay. Yeah, okay. So leave out why this range is 4, 5, 6, 7, 8, 9. I'll tell you.
Yeah.
So I have chosen 10 balls randomly, right?
Yes,
Okay.
sir.
Can I get 0 yellow balls? So suppose, let's say I get 0 yellow balls. What does that mean? Then out of the 10 balls chosen, how many red balls should be there?
10 red balls, but there are
But
only
is it
6 red
possible?
balls.
6,
No, sir.
right?
No, sir.
So that means I should have. So if I choose 6 red balls, I will get at least 4 yellow balls, right? That's why I have to start from 4, and I have to end at 9 uh, because of this. So I wanted to recheck this question once, and I wanted to see that whether this will belong to hypergeometric or not. Actually, I told in the last session I think I will solve this one, but I forgot to discuss. So I'll just discuss it in the next class. Fine. Okay.
Fine, sir. Fine.
Yes, sir.
Sir, can you finish the last
Okay, guys.
question, sir? Last part of the previous question, sir. The one with the bulbs, like defective regulators.
I have completed, no? I told
No,
you, no?
second part was still there, sir.
Yes,
Like
sir.
What is the second part? Can you just tell me the question?
wait a second, sir. It was given that we find 5 out of these 10 regulators are defective, then find the probability that exactly 3 of the defectives came from the line B. Should I repeat, sir? Hello, sir.
Hello.
Yeah, yes, sir. Did you get the question, sir?
Sorry.
Sir has
Am I audible, or is it
Yes,
like
sir. You're audible
audible.
now.
okay? Yeah, tell me. So I lost in between. Yeah.
Given that we find 5 out of these 10
So
regulators
can I leave this meeting? Is this meeting
Yes.
going or long?
No. Just like within 5 minutes, I'll finish it off. Yeah.
Okay, sir.
You can
Then I
drop
leave
off.
this meeting.
Sure. Yes,
given
Sujay.
given that we find 5 out of these 10 regulators are defective, then find the probability that exactly 3 of the defectives came from line B.
Okay, that is a conditional problem, right? The conditional probability problem.
Yes, sir. Like I tried using making tables for it, like sir. Like I did A, B, and like made tables for it, but I did not get the answer. Sir.
Okay. So what I'll do is maybe okay, we'll finish it off today here. Like I'll end this meeting today. This problem I'll take you into the next class when we are having mock discussion, right? I will
Yes,
just
sure, sir.
tell
Sure.
you guys about the conditional probability part and total probability part, like how to solve this using purely using the finding out the events and how to find out the probabilities, because today what we have solved is by using the permutation method, right? But we can have the other methods to solve it. A normal like normally we can find out by using the events. So I'll show you that. Okay, both these questions will be solved. Done?
Okay, sure, sir. Thank you, sir.
Okay. Okay. Bye.
Good night.
Good night.
Thank you, sir.
Thank you guys. Thank you. Yeah. Bye.